To today's lecture on arithmetic and geometric sequence. Today we'll be going through the definition of a sequence and learn about two different specific types of sequences, arithmetic sequence and geometric sequence. And then we'll also go through some sample problems for today on the left. If you're new, make sure to subscribe and turn on post notifications for more math content. So first, in order to learn the different types of sequences today, we need to know the definition of a sequence. Well, the definition of a sequence is an ordered list of numbers following a specific rule or pattern. Now, we'll learn two different patterns from two different sequences. The first one is arithmetic, and an arithmetic sequence is a set of numbers where the difference between consecutive terms remains constant. So that means that as we proceed from one term to another and that pattern keeps repeating, the difference remains the same. And so the formula for an arithmetic sequence will be a sub n is a sub 1 plus d times n minus 1, where the a sub n is the nth term of the sequence. A sub 1 is going to be the first term of the sequence. D is going to be the difference. And then the n is the n term. So that makes sense, right? And then geometric sequence is a set of numbers where each subsequent term is found from multiplying the preceding term by a fixed non-zero number by common ratio. So that means that the growth, or we could call it like decay rate, is not going to be constant, right? Because each preceding term is being multiplied by a constant. And so that means that as each term proceeds, it's not going to go up or down by the same value. So the formula for the geometric sequence, you can look at the left. It's going to be a sub n is equal to a sub 1 times the common ratio r of n minus 1. N is the nth term of the sequence. A sub n is that value of the nth term of the sequence. A sub 1 is the first term of the sequence, and r is the common ratio. Okay, so let's go through some sample problems. The first one, so given a sequence of t sub n, oops, my bad, t sub n is equal to 41, 47, 53. Identify whether the sequence is arithmetic or geometric. Well, just looking at the terms 41, 47, the difference is 6, and 47 to 53, the difference is 6. So I can pretty much assume that the differences remain the same as each term proceeds. So I think that for part A, identify whether the sequence is arithmetic or geometric. We could confidently say that due to the constant difference, the sequence is arithmetic. Okay, part B, derive an explicit formula for the nth term a sub n of a sequence. I think I meant to say t sub n, but that's fine. So what we can do is identify the first term. So this is the first term. So now we have a sub n is 41 plus the d times n minus 1. And we identified earlier that the difference, right, is 6. So that is it. Part C, find the 22nd and 5th term. Okay, so what we do is that to find the let's find the 15th term first. So for the 15th term, the n is going to be 15, right? So n is equal to 15 for this. So this means that we just plug in n into the equation. 15 minus 1, right? So n is 15, we just plug that in, right? So now we have to compute this value. 41 plus 6 times quantity, 15 minus 1. So if we look here, 41 plus 6 times 14 is 41 plus 14 times 6. I think that's going to be 84. Yeah. And the answer is going to be 125. Okay, now going to the 22nd term. We do the same thing. N is equal to 22. So A22 is equal to 41 plus 6 times 22 minus 1. Now I'm just going to plug this into a calculator. If you have a calculator, you can plug it in. Or if you want to do it by hand and do multiplication like that, you can do that. But I got A sub 2, 22 is 167. Simple enough. Okay, now a trickier one. What term is the number 281? Okay, so we're looking back at this equation, right, for part D. It's right up here. A sub n is 41 plus 6 times quantity n minus 1. Okay, so we're looking for um, what term is the number 281. So what we could actually do is that we could just plug 281 on the left side and then just solve for n. So that's going to be 6 n minus 1. Sorry for my bad handwriting, but we get 281 minus 41 is 240. Divide both sides by 6, and you will get 40. So n is equal to 41. So therefore, this is the 41th term of the sequence. So 281 is the 41th term of the sequence. Okay. Okay, let's go on to number 2. Given the sequence of, we'll just write it a sub n, is 15, negative 30, 60. Identify whether the sequence is arithmetic or geometric. Well, I'm gonna look at this difference, right? This is like negative 45, and the difference between negative 30 and 60 is 90. So I can tell that the difference is not constant as we proceed term by term. Therefore, for the purpose of discussion today, we're only doing arithmetic and geometric sequence. So we can tell that this is a geometric sequence. So geometric sequence. Okay. Part B. So now we need to find the formula for this. So a sub n for a geometric sequence is going to be a sub 1 times r to the power n minus 1. Okay, so we could figure out the first term already. I think the first term here, right? This is the first term, and let's highlight it. All right. Excuse. All right. Anyways, that is the first term. So a sub 1, we can conclude is 15. And to find the common ratio, we can actually divide that preceding term of 15 by itself. So the preceding term is negative 30, and then the first term is 15, right? So by that, this is negative 2. So we have basically found our formula. A sub 1 is 15, so plug that in. Common ratio is negative 2, so plug that in. And n minus 1, just keep it there. That n is basically the dependent variable. Just think of it as like a function, right? Where this is the input and this is the output. So the value of those terms is the output, and then the nth term is the input. So think of it like that. Okay, part C. Um, find the 11th and 15th term. Well, just plug it in. A15, sorry, A11. Let's do A11 first. A11 is just 15 times negative 2 quantity. Okay, 11 minus 1. So A sub 11 will be, I think you should pull up your calculator for this, but yeah. So we'll get 15 times negative 2 to the power of 10. So the 15th term is 15,360. That's the answer. Now A15 is plugging in again. Use the calculator once again. And I get this. Okay, part D. What term is the number negative 1,920? So we'll just plug that in for A sub n. We don't know the n yet, but um, we'll figure it out. Now, what I'd like to do is that we can technically divide both sides by 15. So 15 divided by 15 and 1920 divided by 15 is 128. So this is negative 128 will equal to negative 2n minus 1. And these negatives cancel. And if you know your exponents, I think 2 to the power of 7 is equal to 128. So we just basically set n minus 1 equal to 7, right? So n is equal to 8. If you guys don't know exponent rules yet, we'll go over that in the future. But for now, just you're gonna have to follow through the video. Okay. Number 3. Okay, same type of problem. Given a sequence, a sub n is we'll write it as t sub n actually. I think it's supposed to be t sub n. 60, 660, 220, and 220 over 3. Find the determine the sequence. All right. So the difference here, I think it's just 240, and the difference here is just 220 minus 220 over 3. Well, you can tell that the difference is basically not the same. This is going to be a fraction, right? This is a fraction, right? And this is an integer. So by that, we could automatically assume that differences are not going to be the same. They're different values. So yeah. So that means that for this, this is a geometric series for the purposes of discussion today. Part B, drive a formula. Okay, so we could automatically assume that based off what is given, literally, the first term is going to be e sub 1 is 60. Now, to find a ratio, you could do the preceding term of 60, which is 220, right? Divided by 60. So we could divide we could bring out 100, right? So this is 22 over 66, and that's just 2 over 6, which is 1 over 3. Simplify the fraction down. So the formula for this is just going to be 60 times 1 over 3 to the power of n minus 1. Okay, part C. Find the 5th and 7th term. Okay, 5th term, my bad. Okay, 5th term is 60 1 over 3 to the power of 5 minus 1. So a sub 5. Okay, the issue is that I'm getting a fraction on my calculator, so try to do this by hand. So 1 over 3 to the power of 4 is just gonna be 1 over 81. A sub 5 is 660 over 81. We can simplify this fraction down to 220 over 27. Can we do it again? No, I think this is the simplest we could go. Yeah. Okay, now we need to find a sub 7. A sub 7 is it's the plug it in once again. I mean, this part is really simple. Oh shoot. I apologize. Um, A sub 7. Let's actually zoom out a bit. Okay, so we just plug it in again. 7 minus 1. A sub 7 is 660, 1 over 3 to the power 6. And 1 over 3 to the power 6 is just 1 over 729. And try to simplify this fraction further. Okay. Okay. If you just plug it into your calculator, if you have like a TI-84 plus CE, you can probably simplify this fraction using the calculator itself and its features, but this is a simplified fraction, 220 over 243. Okay, let's erase this. Okay, now we want to focus on part D. We need to find the, the term of 220 over 6561. So, all right, perfect. So plug that in for a sub 1, a sub n, and then now we need to find the n, right? So, and the question mark, right? What we can actually do is that we can, all right, we could do this. We could divide both sides by 660. So 220 6561 times 660. Okay, it's kind of unfortunate because this number is really small. You can't really get in fraction form. Okay. Okay, I mean, we're not gonna do this one because I think this one's kind of messed up. We'll fix that in the worksheet, but the the approach is still the same though. So there's nothing new with that. Okay, and then for today's challenge problem, which is an MCQ, the first term in the geometric sequence is 144, and the sum of the second and third terms in the sequence is 540. Which of the following could be the fifth term in the sequence? Okay, so we know that it is a geometric sequence that we're looking at, right? So the first thing is that we can make a sub 1 is 144. That is literally given. Now, the sum of the second and third terms in the sequence is 540. So let's write down a sub 2 plus a sub 3 is 540. Now, how do we define a sub 2? Well, a sub 2 is just 144 of r to the n minus the 2 minus 1, which is just 144r. A sub 3 is 144 times r to the power of 3 minus 1 is 144r squared. So we just sub that in. 540. Now we just move 540 to the other side. and now we have a quadratic, right? So what we're going to do to find solutions for r, we need to use a quadratic formula. And if you don't remember the quadratic formula, it's negative b plus or minus the square root of b squared minus 4ac and then all over 2a. Okay? And we'll just replace the x with the r. So r is negative 144 plus or minus the square root of 144 squared plus, okay, we'll do minus 4 times negative 540 times 144. And I basically just wrote the positive here initially because I knew it was going to be positive since the negatives cancel out, right? This negative cancels out and it becomes plus, right? So, yeah. So we'll just make it like that right now. And then 2 times 144. I'm going to plug in that square root value inside. 4 times 540 times 144 square root that. You're going to get 5/7. So you have negative 144 plus or minus 5/7 all over 288. Just for now, I'm going to actually do the plus. So negative 144 plus 5/7 over 288. So minus 144 divided by 288. That's just going to be 3 over 2. So the common ratio for the sequence is 3 over 2 for the geometric sequence. So now we can rewrite our formula as 144 times 3 over 2. Let's make that a little bit neater. To the power n minus 1. So what could be the fifth term? Well, now we just need to plug it in. 144 of 3 over 2 to the power of 5 minus 1. And finally, we just plug it into the calculator. 4729. That is your fifth term for the challenge problem, for the sequence. Okay, thank you for tuning into this video. Hope you guys enjoyed it. If you haven't, please subscribe and like the video. Turn on post notifications for more math content. There's also a free worksheet attached in the comments, so it'd be greatly appreciated if you please take a look at that worksheet. It's free. There are a bunch of homework problems and as well as challenge problems that test your conceptual thinking. But thank you for watching this video and have a great day.